Newton's third law is basically if an object A exerts a force on object B, then object B will have to exert an equal amount of force on object A in the opposite direction. So we can do this as I can show this as an example of Newton's third law. So let's say we have a box, and let's say we have a person trying to push on that box. Whoops. That this person is pushing on that box, so it's trying to exert a force this way. But the box will have to exert an equal amount of force on that person going this way. Let me make that a different color, going this way. See, kind of makes sense because when you push on a heavy object, you kind of feel like it's hard to push that object because that object is also exerting a force on you as you exert a force on it, on that object. So what is the reaction to the normal force on a textbook sitting on a table? When the textbook is sitting on a table, say this is your book, this is your table. This object is, we'll see it this way, that object is exerting gravity, its mass on the table, Fg. But since the textbook is exerting a force on the table, that table will also have to exert an equal amount of force on the textbook, according to Newton's third law. So for every force, there's always going to be a reaction force going the opposite direction. So this is called your normal force. So we basically just answered the question, but in like a different in a different approach, because on how I see it, the question is kind of like worded wrongly, because I think that the normal force is the reaction force, not the other way around. But it's asking like, what is the reaction force to the normal force? But it's basically the force of the book on the table, which is our gravity. So that's the answer.